In this unit, we're going to look at variation of data. But what is it going to vary around? And usually we're going to be using measures of center and looking how data values vary around that. So let's go ahead and get started by talking about measures of center, which include mean, median, and mode. And I do have a cute math joke for today. It says, my ex-girlfriend thinks I'm mean, and my current one thinks I'm average. Maybe you've set your bar too high. Do you get it? X bar. That's also known as the mean or the average. Anyways, but before we get on to X bar, let's start with the median. And I have an image here at the right that shows the median. All right. And there are two sets of data. Here's the median for this set of data, and there's the median for that set of data. Well, looking at it, what's the difference? Why is the median here just on one data point, and here it's between two data points? If I look at the data here, I've got 1, 2, 3, 4, looks like I have 7 data points over here on the left, and then 7 on the right, and 2 in the middle. Okay, let's go ahead and look at this one. Here it looks like I have 9 data points on the left, and 9 data points on the right, and 1 data point in the middle. So if I look and split off an equal number from both sides, what I'm left with in the center is the median. And by the way, if I'm left with 2 data points in the center, the rule is you go halfway between those 2 data points. So the median is the centermost point that splits the data into 2 equal groups. And notice how the median here is actually kind of on the left. So it's not halfway between the min and the max. It's whatever splits the groups in 2. It's pretty easy to find the median. You order the data from the least to the greatest and remove an equal number of points from both ends till you have 1 or 2 data points in the center. If there are 2, take the average. That's the same thing as finding the midpoint right there. If there's only 1 data point, that's your median. All right, so let's take a look at an example. We have a weightlifting team had bench presses of 115 pounds, 137 pounds, 160 pounds, and 89 pounds. And what is the median score? I really should say weight there. So let's reorder the data from least to greatest, 89, 115, 137, and 160. Then I have to lop off an equal amount of data from both sides, but leave something in the middle. Well, I can only lop off 1 from each side. And that leaves me these 2 in the middle. Since there are 2 data points, I'm going to have to take the average. And I get 126 is the median weight. So half the weightlifters lifted below 126 pounds, and half the weightlifters lifted above 126 pounds. Now, a fifth member of the team also competed. If the new median score is 123, how much did the fifth team member bench press? Well, I'm going to go ahead and list them all out and then put a blank for any place where I could put a new weight. So my new weight could be lower than 89, between 89 and 115, between 115 and 137, between 137 and 160, or even greater than 160. Now, if my new team member lifted, say, 70 pounds, then that median would now be 115 instead of between here. Even if he lifted 100 pounds, it still would be 115. If he lifted 170 pounds, that means my center would be 137, right? Even if he lifted 150 pounds, my median's still 137. So that means I want my center, my median has to go here. And if I want the center to be 123, it has to be 123. Now let's go ahead and take a look at mean. And I know you're very used to calculating means, but I thought this was a cool way to look at it. Essentially, I have, say, 4 bags of apples here. And what do you notice with the 4 bags in the before and the 4 bags after? Well, basically what I did is I moved apples around. So I moved one there, and that one there, until I had an equal number of apples in each bag. So the mean is really the value in each group after dividing the total equally between the groups. How do you do it? You guys know how to do this. You total the data points, and then you divide the total into equal numbers so that each data point would have the same value. Okay, in this example, students were polled on how many people lived in their house with the following results: 3, 4, 6, 3, 5, 6, 5, 5, 6, 7. What is the mean number of people in each house? Now, I know you know how to do this. I'm actually going to show you a cool way to do it, which is kind of knocking things off the big piles and redistributing them like Robin Hood onto the little piles. So that 7 looks mighty big. Let's knock off 2 and put it on that 3. And one of these 6s can definitely take one off, and we'll put it on that 3. So now I have 5, 4, 5, 4, 5, 6, 5, 5, 6, 5. So my biggest piles are 6s. Knock one off of there and put it on that 4. Knock another one off of that one and put it on that 4. So I have equal piles of 5, which tells you the average is 5. It won't always work real pretty this way when the answer is a decimal, but when it's an integer, it works pretty well. But you can always use the usual method, which is, I don't know, it's not as exciting. Add up all the values, divide by how many data points, and you get your answer of 5. Now, Tabitha has a mean of 78 on 5 assignments. She wants to get a wristband, which is a prize. So what does she need to make on the next assignment to bring her mean up to an 80? As a teacher, I get this question all of the time. So here's how you can calculate it yourself. All right. If it's for a group of equally weighted assignments. Well, if Tabitha has a mean of 78 on 5 assignments and she does one more assignment, how many assignments will she have? She'll have 6. So her total number of points, if she's going to average 80 on 6 assignments, that's like having 6 80s or 480 points. So this is Tabitha's goal. What does she have right now? Well, she has a 78 on 5 assignments. So how many points does she have? Well, I multiply it out and I get 390 points. Therefore, she has 390 points now. She needs 480. I can subtract them and find out she needs to make a 90 on her next assignment. So you might find this coming in handy, especially when you ask a teacher who's not as who doesn't like math as much as I love math. But even so, usually it's very hard for us to go do these calculations. You can go do it yourself and get better at math while you're at it. All right, so we've learned about the mean and the median. Those are two ways to describe the center of data. Which one is better? Well, let's go ahead and do a look at the mean and median for this survey. I surveyed how many countries various students had visited outside of the U.S., and here's the results: 311,002,0113. I'm going to go ahead and find the mean by adding them all up, dividing by 10, 1.2. Going to find the median by listing them in order and then crossing off equal sized groups. And I can see the mean is 1.2 and the median will be 1. Now, I have actually been to 25 countries outside of the US. And next year that'll go up to 27, but for right now, 25. If we add this data point, what happens to the mean and the median? Well, my total number of points was 12. I'm going to add 25. So 12 plus 25, not only that, the 10 changes to 11 because I added an extra data point. So my new mean is 3.4. And then my median, I'm going to go ahead and put them in order again. And the only thing that I added there was a 25 on the end. Strike off an equal number of data points on both sides. And you see that I have a mean of 3.4 and a median of 1. The median did not change because putting that 25 didn't really slide me out of these groups of ones. I would have had to add a lot more higher data points. I could have added a bunch of 3s, and then that would have changed my median. But adding one data point didn't really change it. What did change was the mean. And why is that? Well, that 25 is really what we'd call an outlier, and it's pulling the mean up. So the mean is affected by outliers, but the median is rarely affected. So when there are outliers, the preferred measure of the center is the median. Again, now that you know how to calculate both of these, it's nice to use it to determine symmetry. Remember, a mean is going to be on pulled towards the outliers. So this graph right here is skewed left. Which one's left, the mean or the median? Well, the median's the halfway point for the data, right? So it's in there somewhere. But the mean's going to be pulled down by these lower values here. So if the mean is less than the median, it's skewed left. Roughly symmetric, and we rarely have data that's perfectly symmetric, is when the mean is roughly equal to the median. And there's no hard and fast rule how far apart they can be. You can just say, well, okay, they're pretty close or they're not so close. When they're not so close, you should know it's skewed. All right, and then when it's skewed right, it's basically the mean is on the right side of the median. Now here are some geometry quiz grades, and we're going to calculate the mean the old-fashioned way. There they are. Add them up, divide by 10, and 83.8 is the mean. Now let's do the median. I put them in order. Cross off an equal number of data points. I got these two left in the middle, so I better average them, and I get 90.5. So how would I describe the symmetry of the data? Well, the mean is left of the median, so I'm going to say it's skewed left. It's noticeably lower than the median, and not only that, that quiz score of 50 is definitely pulling the average. You could even argue that the 70 and 71 are kind of pulling it down too, because the halfway point is like a 90. So you have half of your grades are over here in the A territory. Then you have one that's barely a B, and then there's almost a B, and then these are way down below. So those are skewed that way, skewed left. Now, last but not least is the mode. And I have this graphical image here that shows 8 bags of apples, all right? And I put in gray the mode. So you might remember from 6th grade or 5th grade, what is the mode? It is basically the most common value for the data point. So the most common amount of apples in a bag here is 7. All 4 of these bags have 7 apples. And then the rest, well, they don't, these two match, but even if you have repeats, they don't get to be the mode unless you're the highest most common value, all right? In terms of the most common. I don't mean it has to be 8 compared to 5, but I have 4 bags of 7. If I had had 2 bags of 10 here, that still would not be the mode. Okay, in this example, we're going to revisit the people in the house. Now, the teacher's going to add the number for the people in her house, and the mode is going to become 5. So how many people live in her house? Well, I'm going to go ahead and put them in order because that makes it, and then I'm going to put my new data point here. Right now, the mode is 5 and 6. By the way, you can have more than one mode. They just have to be tied in how many of them there are. Since I have an equal number of 5s and 6s, and they're the most common, my mode is 5 and 6. All right. If I didn't have any repeats at all here, then I would say I have no mode. So we want the mode to be 5. Well, the only way that'll happen is if I get another 5. Now that I did that, I can determine the new median. So I'll reorder these so I can do my median. And the median's 5. And I'll go ahead and do by hand, rearrange, and find my new mean. So take 2 off that 7, put it on that 3. Take 1 off that 6 and 1 off that 6, put it on that 3. Take 1 off that 6, put it on the 4. And you can see my mean is 5. Finally, the mode is 5 because that was the whole point. We were trying to make the mode 5. Last example. Joel rolled a die 7 times and he got 3, 4, 3, 6, 1, 2, 3. If he wants the mean on 8 rolls to be the same as the mode, what should he roll on the next turn? Well, so far, let's find out how many points he's got in total. Well, he's got 22 points when I add up all these rolls, okay? I want the mean to be the same as the mode. Well, I've got 3 3s and no other repeats. Even if I added another 6 or another 4, I'd still have more 3s. So the mode's not going to change. It's definitely 3, all right? Which means I want the new mean to be 3. And if I want it to be 3 with 8 rolls, 3 times 8, I need 24 total points. I've got 22 so far, which means he needs to roll a 2 because he's only 2 short of 24.